Happy Tuesday. First week is done. Brand new week. What we're going to be looking at today is technically Calc 1. We're going to be looking at several techniques for evaluating integrals of trigonometric functions. Right. I say this is technically Calc 1 because all you need for the most part are trig identities. Right, so the idea is going to be to try and simplify the integrand using trig identities and then evaluate the antiderivative. There are a few that you are going to need integration by parts, but for the most part, all of this should be Calc 1. Now we need this because what we're going to look at next is our second technique of integration known as trigonometric substitution, which converts your integrand into a trigonometric integrand, right? And then you need to evaluate it using these techniques. And then do backward substitution. So it's a really fun technique. Yeah, this is attached to this. So let's start with, why are the authors not hidden? I thought I hid you. Thank you. Let's start off simple with sine squared. Okay. Well, you could try and write 1 minus cosine squared. Well, that just brings you right into the same boat. How do you evaluate the antiderivative of cosine squared? So that really doesn't help. We could try and do integration by parts. We don't have to. We can use the sign reduction identity. So sine squared of x, 1 minus cosine of 2x all over 2. That is the sign reduction identity from trig. And of course, that is on the review of pre-calculus sheet that you have in the Teams files that you'll be able to use all the time.
Derivative of sine squared is 1 minus cosine 2x.
Antiderivative of 1 minus cosine 2x all over 2.
Okay.
Right, all I did was reduce sine squared to 1 minus cosine 2x over 2.
Sine squared is the same thing as that.
Yes.
Okay.
Right, that's the identity. And you can factor out the 1/2. Well, we know what the antiderivative of 1 is. Antiderivative cosine of 2x. Antiderivative of cosine is sine, right? What is the derivative of 2x? So chain rule would say you have to multiply by 2. U sub would say you have to multiply by its reciprocal. Antiderivative cosine of 2x is a half sine of 2x. Remember, you can always verify that that's correct by taking its derivative. And derivative sine of 2x is 2 cosine 2x. Multiplied by 1/2 gives you cosine of 2x. So there's one form. That's probably not the form that's going to be in the book or on the table. Does anyone recall the double angle identity for sine?
The double identity for.
Double angle identity for sine.
For sine. Sine x.
So sine of 2x is 2 times sine x times cosine x. Why is that a plus? That should be a minus. That's probably what you'll see in the book. Does that mean that that answer is incorrect? No. They're the same answer, just written differently. Right, so you could have that answer. The back of the book will have this answer, and you'll think you're wrong when you're not.
I got lost. Where did you get 1/2 sine 2x from?
U sub. U sub. For cosine of 2x, let u be 2x. What's the derivative? So u substitution, change a variable from calc 1. And it's calc 1. Oh, because I did it in my head. Right. So just write out u equals 2x, right? Oh, that's right. It's because I have that highlighted. What's the derivative? Do you see a 2? Dx? No, right? There'd have to be a 2 in front of that cosine. So I'm putting a 2 there. But I also have to multiply by 1/2 if I'm going to do that. That's where the 1/2 came from. So how I always thought of u sub was, instead of multiplying by the derivative, you multiply that by the reciprocal of the derivative. Right. So if the derivative was 2, I'm multiplying by 1/2. That's how I've always thought of it. What about sine cubed? Yeah, this is where we're gonna have to get a little fancy.
Well, it's sine times sine squared, so you plug in the formula from earlier.
What formula?
The 1 minus cosine of 2x over 2.
So how would that help you?
Because then you can multiply out.
Right.
And
That'll give you sine of x times cosine of 2x. Right, you'll have that in there.
Okay, well that will be.
How would that help you? You can do that, by the way. It's going to require more algebra than what I'm going to do. That would be valid. Right, because there's an identity, it's a product, it's called product sum. So if you have cosine of alpha times sine of beta, that's a product sum identity. So that would be valid, but it's more algebra. What is the derivative of cosine? I have a sine, don't I? So if I can somehow get a cosine in here and do u sub, we're golden. Oh, but isn't sine squared 1 minus cosine squared? There's my cosine. So let u be cosine. We're going to now wind up with negative antiderivative of 1 minus u squared, which we can go ahead and actually distribute that negative through and write it as u squared minus 1 instead. Antiderivative of u squared is what? And then, of course, we have antiderivative of 1, which is just u. However, the original variable was x, wasn't it? Not u. So we have to do backward substitution. Remember that? We said u was what? Cosine? So there's the antiderivative for sine cubed.
Is there some alternate form of that that we want to?
Probably not. The book will tend to try to simplify if it's like trig of like 5x or something. They want to try and write that in terms of only x's. That might, I think that's the only simplification they really do. Sine squared times cosine cubed. Well, here we look. Derivative of sine is cosine, right? Derivative of cosine is negative sine. Well, right off the bat, we can't do u sub. Right, because that's a cosine cubed and a sine squared. So you're going to have that extra trig function left over regardless. But take a look. Power of sine is even. Power of cosine is odd.
So separate the cosine. Then we had cosine. Sine squared. Like that.
Right? So if you pull out just one cosine, well, now we have cosine x dx, which means we're going to want to do u sub with u equal to sine. But that cosine squared throws a wrench into that, right? But we have a Pythagorean identity. Right, cosine squared is 1 minus sine squared. Now, do u sub, let u be sine. This antiderivative becomes what? U squared times the quantity of 1 minus u squared. Distribute the u squared through. Now that's just a simple power rule and difference rule. So antiderivative of u to the fourth. And don't forget your constant of integration. That's just a matter of replacing u with a function of x. And there's your antiderivative. And by the way, you would have a similar process if the power of sine was odd and the power of cosine was even. Right, except then you try and do u sub with u equal to cosine instead of sine. But what about sine to the fourth? You could use the sine reduction formula that was derived, right? That was derived using integration by parts. But you do not need integration by parts here. Isn't sine to the fourth sine squared squared? Well, again, you could say, okay, sine squared, 1 minus cosine squared. But then that would leave your problem of when you expand that out, you're going to have a cosine squared and a cosine to the fourth. Which kind of defeats the purpose. But sine squared can also be reduced using the power reduction identity. Right, so 1 minus cosine 2x over 2 all squared. Right, so to make life easy, remember the exponent distributes to both numerator and denominator, right? So you can factor out a 1/4. Then we're left with 1 minus cosine of 2x quantity squared, which is a binomial expansion. Right?
So you'd factor it out and then you get 1 minus 2 cosine of 2x plus cosine squared, and then you could change
Cosine squared of what?
Of x, okay.
Not x.
Oh, 2x.
Right. Cosine squared of 2x. That's exactly what we're going to do. So let's start there.
And then, I mean, I think you can do it, turn it to 1 minus sine squared of 2x so that you can use the thing previously did.
You can, but why would you do that when there's also a reduction identity for cosine? Right. So again, you can. It's perfectly valid, and you'll get the exact same answer. but it'd be a little bit less work just to use the reduction identity for cosine, right? Cosine squared of x. 1 plus cosine of 2x all over 2. So it's the exact same as sine, except instead of minus, it's plus. But remember, our angle this time is not x, right? It's 2x. So it'll be 1 plus cosine of 4x all over 2. How badly do I not want to deal with fractions? But that's why I said, how badly do I not want to deal with fractions? Do I want to go ahead and factor the 1/2 out and then deal with that, or just leave it? And I think I'm just going to go ahead and factor out the 1/2. So I'm going to factor out 1/2. Right, remember, factoring out is the opposite of distributing. So when you distribute, what do? You multiply each term by what you're distributing, right? So if you're factoring, you're dividing each term by what you're factoring out. So if you factor a 1/2 out of 1, you're left with 2. 1 over 1/2. I'm going to do two things at once, because we're also factoring a 1/2 out of 1/2, right? Which is 1. So 2 plus 1 is 3. No, that should be a 4. So that is what we should be left with. And again, you're factoring 1/2 out of 2, so you're left with 2 times 2, which is 4. Ah, well, now this is really straightforward, right? Antiderivative of 3 is 3x. Antiderivative of cosine 2x is 1/2 sine of 2x. Antiderivative cosine of 4x, 1/4 sine of 4x. All right, so then just distribute that 1/8 through. And that's what you get as your antiderivative. Right. So the question now boils down to, that answer is perfectly acceptable. How far do you want to go? Okay. Word of warning. Let's say, and 2 of you are already aware of this, because I did the same thing in Calc 1. Let's say you have that on the test, right? You write that down, and then you try to simplify it. Try to be fancy and show off. And you make a mistake. I had to grade that, so you're losing points. Versus if you were to stop here, you would have gotten full credit. So if you're going to try and be fancy, I am going to grade it. And if you make a mistake in that fanciness, you will lose points for it. I also tend to count as your answer what you have boxed. So even if you have that and then a different answer boxed right next to it, I'm probably going to take the box as your answer and take points off. So be careful. So the question really is, how far do I want to go? Do I want to try and simplify that? I think I do, just to show you how messy it can get. I'm going to try and write it so that it's only x. Right, so I'm going to try and get rid of the 2x and the 4x. Because that's typically what the book does. Right, so if you look in the back of the book, that's not the answer they're going to give you. They're going to try and write it all as just x's. Don't ask me why they do that. So 3/8 x minus, all right, so sine of 2x we know. 2 sine x cosine x. Now, sine of 4x would be 2 sine of 2x cosine of 2x. So it would be what? 1/16 sine 2x cosine 2x. Plus our constant. What I think I'm going to do is I'm going to just put a box around there to signify that that would be acceptable. Right. Well, sine of 2x, right? 2 sine cosine. That'd be 1/8 sine times cosine. But now we need to do something about that cosine of 2x. Double angle for cosine of 2x. There are 3. It's just a matter of which one you want to use. Yeah, go ahead.
1 minus 2 sine squared a.
All right, that's one of them. If you have them.
2 cosine squared a minus 1.
That's the second.
Cosine squared a minus sine squared a.
Which is the most commonly used. Right, so the identity itself is actually cosine squared minus sine squared. But then using Pythagorean identities, you can rearrange that to either 2 cosine squared minus 1 or 1 minus 2 sine squared. Doesn't matter. All 3 would be valid. Notice we would have an advantage if we used either 2 cosine squared minus 1 or 1 minus 2 sine squared. Then this term multiplied by 1, right? And then we'd have like terms to combine. So instead of having what? 4 terms, we'd have 3. So now the question is, do we want cosine squared or sine squared? At that point, it doesn't really matter. If I do 2 cosine squared minus 1, I'll have a negative. That 1/8 will be minus 1/8. If I do 1 minus 2 sine squared, then that would become positive. I'd rather add fractions than subtract fractions. Right, I'd rather have a positive fraction than a negative. Again, it doesn't matter. So I think I'm going to do that one. I'm going to do 1. Oh, wait, no, that would be negative, wouldn't it? 1/8 is smaller. It would still be negative. Oh, crap. Well, I'd rather have 1 negative than 2, so I'll use 2 cosine squared minus 1. Half plus an eighth. 5/8. So that would be simplified. That might be what you see in the back of the book. Again, I can't say for certain because I don't know what identity they're going to be using. I don't know if they're going to use cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. But generally speaking, that's what they like to do, try and write it all in terms of just a single x. Yeah, whatever's box, that I'm perfectly okay with that. Right. I'm happy with that because I at least know that you know the process. Sine squared times cosine squared. Well, in this case, both powers are even. So we're not going to be able to do what we did before, right? Split one of them off, right, and try and write like, so not split sine off and have a single power of sine to do u sub, or split cosine off and have a single power of cosine to do u sub. That's not going to work. So we're going to have to use the Pythagorean identity, sine squared plus cosine squared equals 1. To either rewrite sine squared or cosine squared. It does not matter which one. Right. Typically what you would do is you'd want to choose the lowest power one to rewrite. Right, so if that was like sine to the 4th times cosine squared, I'd rewrite cosine squared. But it's not, they're both the same power, so it doesn't matter, you get to choose. What did I do in my notes? Oh, I did something even fancier. I like what I did better. I don't know what the hell I was drinking when I did that, to think of that. Okay. Right, so sine squared times cosine squared would be the same as sine times cosine all squared, right? If sine of 2x is 2 times sine times cosine, then wouldn't sine times cosine be half sine of 2x? So sine 2x, double angle. 2 times sine times cosine. So sine times cosine, 1/2 sine 2x, right? Just divide both sides by 2. But now that gives us a sine squared. Just sine squared. Which would allow us to use the reduction identity. Right, sine squared, 1 minus cosine of 2x all over 2. Factor out the 1/2. Antiderivative of 1 is just x. Antiderivative cosine of 4x is 1/4 sine of 4x. And so there's the antiderivative. Right, let's just say that we tried to rewrite cosine squared or sine squared, right? It's going to be the same thing. Right, except if you rewrote sine squared, it'd be cosine to the 4th minus cosine squared. What you would then have to do, well, sine squared is easy enough. You could then either use the reduction formula on sine to evaluate antiderivative sine to the 4th, or do what we did before, which actually don't reinvent the wheel, right? We already evaluated that antiderivative. Right, so we already have the antiderivative sine to the 4th, right? So look more hideous, right? More algebra, but you get to the same answer. This is why trig is sexy. So many different ways you can approach the problem. And if you plan on moving on to Calc 3, you better really like trig. What about sine of 3x times sine of 2x? All right, so now the angles are different. If it was a sum, it would be simple, right? Sine of 3x plus sine of 2x, that antiderivative is really simple, but it's not, it's a product. And anti-differentiation does not distribute across multiplication. Well, there are what's known as the product to sum identities. For some reason, I don't think these identities are actually on the handout. I think they have the sum to product, but not product to sum. You can derive the product to sum from the sum to products. I'm just going to write out the one I'm using. So we're going to have to rewrite sine of 3x times sine of 2x using this product to sum identity. Yeah, factor out that 1/2. 1/2 antiderivative. Cosine of 3x minus 2x. minus cosine of 3x plus 2x. Oh, now that's a simple antiderivative, right? Antiderivative cosine of sine. Antiderivative cosine of 5x is 1/5 sine of 5x. Oops. Then distribute that 1/2 through. And then I am almost positive the book would do some fancy sum the product formula on sine of 5x to write it in terms of sine and cosine of x and 4x, and then use the double angle identities to reduce it further. So that you get a bunch of functions of only angle x, which would be a lot more hideous than that. I like trig, love trig, but I ain't got time for that. Time is money. So I'm just going to leave my answer in that form. I challenge you to do that on your own at home. Try to write this now as sines and cosines of just x. Actually, I did do it in my notes, but I'm not doing it. Sine of 3x times cosine of 5x. Well, again, you should notice that's different angles. So you cannot use u sub. Right? What's the derivative of sine of 3x? Be 3 cosine of 3x, right? There is no cosine of 3x. Derivative of cosine of 5x would be negative 5 sine of 5x. There is no sine of 5x. U sub does not work. We have to use this product to sum identity. Got the 1/2. And so we'll have sine of 3x minus 5x. Negative 2x, isn't it? Plus sine of 3x plus 5x. Sine of 8x. I really do not like taking the trig of a negative angle. I don't like having the negative inside. You should remember that sine is odd. Cosine is even. That means that sine of negative x is negative sine of x. That's what it means to be odd. Cosine being even would mean cosine of negative x is equal to cosine of x. So I'm going to write sine of negative 2x as negative sine of 2x. It does not affect your results. Antiderivative of sine of 8x. So what's the antiderivative of sine of x? What is it? Negative cosine. So antiderivative sine of 8x would be negative 1/8 cosine of 8x. Then plus 1/2 cosine of 2x. Then distribute that negative 1/2 through. And there's our antiderivative. And again, you can do fancy stuff to get rid of the 2x and 8x and write it simply in terms of x.
That's supposed to be 1/2 sine 2x? Or was there transformation x?
You mean this here? No, I just use the fact that sine is odd. So now what about cosine of 4x times cosine of 2x? Again, different angles. So we're going to have to use this product to sum. Cosine of 4x minus 2x plus cosine of 4x plus 2x. And now it's just simple antiderivative. 1/2 sine of 2x, right? Plus a 1/6 sine of 6x. Then distribute the 1/2 through. And there would be our antiderivative. What about tangent to the fourth? We're going to do this using purely Calc 1. Right, you could use the tangent reduction formula, which would be integration by parts, to derive that formula. But we don't need it. Tangent to the fourth, isn't that tan squared times tan squared?
Could you derive the tangent reduction formula by taking the sine reduction and the cosine reduction formula? And
No,
derive-
because the integration does not spread across division either.
I didn't mean like integrating, I just mean like the reducing formula.
Right, but you're saying that because tangent sine over cosine.
Yeah.
Right, no.
Oh, so that'd be hard to do.
It would not work that way at all. You'd have to do tangent cubed times tangent and then integration by parts that way. Tangent squared. Secant squared minus 1. I'm going to pick one to write a secant squared minus 1 and leave the other one alone. Distribute the tan squared through. Then that lone tangent squared, going to write as secant squared minus 1. Begin with that piece. What is the derivative of tangent?
Secant squared.
Let u be tangent. that first piece is essentially just the antiderivative of u squared, right? Which is 1/3 u cubed. What is the antiderivative of secant squared?
Tangent.
And then, of course, the antiderivative of 1. X. And so there is the antiderivative of tangent to the 4th. So there was no Calc 2 done throughout this entire problem set. It was all just using trig identities and then using the techniques from Calc 1. Hope you're comfortable with trig. Otherwise, you're not going to have fun with what's next. Any questions there before we move on?